Yeah, is the screen visible now? Hello?
Yeah, it's visible.
Okay. Fine. So last class I had introduced a special function which is the modulus function, and we had learned how to redefine those functions. That's actually very important because you'll be asked questions based on inequalities also on that. Not only equations, but inequations can also be asked on those redefinition of functions. So in today's class we are going to dive more into modulus. And last class we ended up discussing that if you have a function y is equal to f of x, and I have to draw the graph of y is equal to mod of f of x, there was a simple rule that we used to follow. Whatever was the part above the x-axis, we never disturbed that part, but whatever was below the x-axis, we reflected it about the x-axis up, right? So in light of that, just a few equations that we will do now. Okay. So let's say I ask you this question. Plot the graph of y minus 3 is equal to uh, x minus 2 mod. Yeah.
Yeah. So y minus 3 equals x minus 2 mod. Okay, so first you take the graph of y equals mod x.
Very good.
That's the graph. So that comes that will come the tip. I mean, the vertex sort of thing will come at the origin for that, right? At 0.
Right.
Y equals 0.
Right. So it will become
Okay,
like
and then it's the whole thing is shifted 2 units to the right and 3 units up. So its vertex comes at 2, 3.
Absolutely, very good. So now it has got moved like this. Okay, so this point, right, which is the corner point, now has come at 2, 3. Okay.
Yeah.
Great. Now let's look into those cases where you are just modding x. Let's say I give you a function f of x, and the graph of it is like this. I'm just giving you a hypothetical situation. Okay, just let's say I have a function like this. This is a curve like this. Okay. Okay, let's say some hypothetical function is this, and this is the graph of that function. Okay. Now, what effect will this function undergo if I just mod the x part of it, not the entire thing? So there's a difference between modding the whole function and modding just the x part.
Correct.
So what will happen if in this very function I just want to plot the graph of y is equal to f of mod x? Just think carefully and tell me what effect will it have, and if possible, draw the graph for f of mod x.
Okay, fine. So mod x, meaning that it will that if there's a negative value give out the x, so the output of that will be a positive value. So if it is going to be a positive value, okay, 1 second.
Take your time, no issues. So
Okay, so I'm
more.
not very sure, but with the curved part, because it is on the negative and on the and then on the y-axis. I don't know.
Okay, okay, let me help you in this. See, when you say mod of x means you are making
Yeah.
this entire thing as a positive input, right? This entire thing should be positive.
Yeah.
Correct? Now that doesn't mean x
Yeah.
cannot be negative. X can be negative, but the output of mod will always be a positive quantity, right?
Correct.
So
Yeah.
let's say I tried to put -1 as x. So when I put -1 as x, the function will perceive as if it has been given 1 as the input.
Okay.
Correct?
Yeah. Okay.
If I put a
Fine.
-3 as the value of x, the function will perceive as if it has been given 3 as the input. Okay, so
Okay.
actually I'm drawing the graph at -1, and actually I'm drawing the graph at -3, but function will pull out those values which it knows is f of 1 and f of 3 respectively for these 2 points.
Okay.
Okay, so
Fine.
let's say
Got it.
f of 1 is this value. Let's say f of 1 is this value. Correct.
Mm-hmm.
So for f of -1 also the same value will get replicated. Are you getting this point?
Okay.
But
Okay. So f
but
minus one also. Okay. Fine.
but
Got it.
but what will happen to the positive values of x? Those will not remain, those will not change at all,
The
because even if you do f of mod
six.
1,
Yeah.
it is f of 1. So when you are already in the positive values of x, the function will exactly trace the same graph as it was. So this will not disturb this part.
Oh.
Correct?
Okay.
So this part of the
Yeah.
function would be undisturbed. The one which is on the positive
Okay.
x-axis, that would be undisturbed. Okay?
Mm-hmm. Oh, understood.
And what it will do
So.
is, for the negative values, it will start copying the same graph which it had on the positive x-axis. That means the same graph here would start getting copied,
Oh, but oh, okay.
right? And this part it will ignore. This part would be ignored because they will never be able to plot this curve, because they came for negative inputs. And no matter what, f can never realize a negative input. Even though x is negative, mod x will make it as a positive quantity.
Yeah.
Understood?
Okay. So that's why. Okay, it's ignored.
It's ignored.
Hmm.
Therefore, the rule here is, let me write down the rule for you. The rule is, if you want to plot the graph of y is equal to f of mod x, okay, then first step is plot the graph of y is equal to f of x. Second step is,
Uh,
don't disturb,
don't disturb the part on the positive x-axis.
yeah, don't disturb the part of the graph on the positive x-axis.
Okay.
The graph on the positive x-axis.
Okay.
And third step is reflect the graph on the positive x-axis about the y-axis,
Okay.
ignoring the part which was already in the negative x-axis.
Okay. So it reflected out the positive y-axis, and then you ignore that it was already on the negative x-axis.
Negative x-axis, absolutely. Okay, so let's
So
take
you
a.
basically wait, you ignore it because it was because absolute value of x is never negative. So that's
Negative.
why you ignore the part on the negative x-axis.
Yes, the negative x-axis graph came because of the fact that the function was given a negative input. Correct.
Yeah.
But this time, because there's a mod of x involved, you will never be able to give the function a negative input.
Yeah. Okay.
So that
So
part will never be able to, the function will never be able to trace that path.
okay, fine.
So
Fine.
functions is like machine. So when you are putting some value into it, it gives you an output, and that's what we trace.
Correct.
So
Okay.
since it will never get a negative input, it will never be able to trace those parts which were in the negative x-axis direction.
Okay, understood.
So let's say I want you to plot the graph of y is equal to mod x square minus 3 mod x plus 2.
Minus 3 mod x plus 2.
Yeah.
Okay. So if we were like that, then okay. So first, you draw the curve without the mod.
Right. Absolutely. So step number one.
Yes, so draw simply the curve, ignoring the mod first.
Yeah.
So that's going to be y equals x square minus 3x plus 2.
Yeah.
So how's the curve? So it's going to have its roots at x equals 1 and x equals 2,
Right.
and its point is going to be a minimum point, right? Let's see.
Yeah. That would be a minimum point between 1 and 2. So it will be coming like this for you.
Yeah, it'll be coming like yeah. So
Okay.
minus. Yeah, it's
Other
going to be minus 1.5.
alternately, you can do one thing. You can actually complete the square here as well. So you can do x minus 3 by 2 whole square.
Yeah.
Okay. And plus 1 by 4. 1 by 4 is half square.
Okay.
So if you do this also, sorry, minus 1 by 4, not plus 1 by 4. So this will give you 9 by 4, right?
Yeah.
9 by 4. I need an 8 by 4. So 8 by 4 will be minus over here.
Okay.
Okay.
Yeah.
So in this way, you can actually shift the graph of x square 3 by 2 units to the right and 1/4 down.
Correct.
So this point is at 3 by 2, comma minus 1 by 4.
Yeah.
Okay, that's another way to draw it. And of course, your way is also correct. You already know the roots of the graph, which is at 1 and 2. And it's an upward opening parabola. Why? How do I know it's an upward opening parabola? Because
X is positive.
yeah, the coefficient of x square is positive. So you can
Yeah.
also trace it like
Yeah.
this. Now, when it comes to modding just the x value, remember we had discussed we will not disturb the part which is already on the positive x-axis. So this
Yeah, and and for the one on the negative side, we don't we ignore that part. And then what we do is we simply reflect it.
absolutely.
Yeah.
So this
But
would be
that
the graph
we
of
do.
mod of x square minus 3 mod x plus 2. Now actually it's stupidity to write mod of x square because mod of x square and x square would be the same. So even if you try to plot this, your result would not change, right?
Yeah.
This is because mod x square and x square are the same things.
X.
Okay.
Yeah.
Let's try to see on GeoGebra how does it turn out on GeoGebra. So y is equal to x square minus 3 absolute value of x plus 2. See this graph?
Yeah.
Right?
Got it.
Yeah. So that's how the graph is being done.
Answer.
Let's take few more questions. Let's say we have to draw the graph of uh, y minus 1 is equal to mod of x minus 3 plus 4.
Okay. Okay. So y minus 1 equals 1 by mod of x minus 3
3
plus.
plus 4. Yeah. How should we plot this graph?
Okay. 1 second. Okay. So this is hmm.
So of course you'll start with this step y is equal to 1 by x, right?
Yeah, y equals 1 by x. So, and then, okay, it's 1 by x, and then it's shifted to the so the same graph is shifted to the right by 3 units, and then
Shifted to the right by 3 units. That means you are doing this now.
yeah, correct.
Okay. Are you sure about this step? Okay, fine. Let's go ahead. Let's see whether if an error comes, we'll come back.
Okay,
Mm-hmm.
fine.
Mm-hmm.
So okay, and then um,
What is the
okay,
next plan?
you shifted down. No, yeah, you shifted up by 1 unit. That will
Okay,
be
that means you are planning to do this.
yeah.
Okay, go ahead.
Okay, then um, okay, then I have to do a plus 4. Okay, where did that come in?
That's the problem. That's what I was worried about.
Yeah, how do you bring the plus 4 in?
Now see, let's go back in the sequence of steps.
Mm-hmm.
Okay. Instead of doing this, you can actually do +4 here first.
Okay.
Okay.
Yeah.
Then, of course, you can shift your y as well.
Okay.
That means you bring your graph 1 units down.
Yeah.
Then here comes the time that you put a mod. So here you just mod your x. Correct?
Okay. Fine.
And then the fifth step would be shifting the graph 3 units to the right. That means you are now replacing your x with x minus 3. So that's how we end up getting to this graph.
Okay.
Okay, so sequence of step is first we go to the graph of the rectangular hyperbola that we studied the last class, y equal to 1 by x.
Okay.
Then we shift the graph 4 units to the left.
4 units to the left.
Yeah,
Okay.
this is shifting 4 units to the left. 4
Mm-hmm.
units to the left.
Mm-hmm.
This is the shifting of the graph 1 unit down.
Okay.
Okay, this is like modding the x, means whatever is on the right side you reflect it to the left side, and whatever was on the left side you ignore it.
Yeah.
And then again this is shifting the graph 3 units to the right.
Okay. So this was okay. Fine. Understood.
Understood?
Okay. Yeah.
If you don't follow this sequence of steps, in fact few of them can be up and down, but you have to mod first and then introduce x minus 3.
Okay. Fine.
Getting the
Understood.
point? So what
Okay.
I'll do
Fine.
is I will
Yeah.
I'll replicate this on GeoGebra, and there you can understand how the graph comes out.
Okay.
So first step was getting the graph of y is equal to 1 upon x. Okay, that's figure like this.
Mm-hmm.
Okay. Next
Yeah.
step is I'll change my x with x plus 4. So what I'll do is in the denominator I'll add a 4. Just see the reflect.
Okay.
So graph moves
Oh
4
yeah.
units to the left. Correct.
Yeah.
Then I will change my y with y minus 1. Graph will go 1 units down.
Okay.
Sorry, 1 units up.
Yeah.
My mistake. We wrote a 1 unit
What?
down. Yeah. So let me just make a correction over here. We wrote by mistake 1 unit down. So it will 1 unit up. Because you're changing y with y minus 1, right? Had you changed your y with y plus 1, it would have gone 1 units down. This is 1 unit
Yeah.
up.
Yeah.
Okay.
Yeah.
Now next correction that we are making in the graph is we are making x as mod x. Correct? So
Okay.
this x I'm replacing with absolute value of x.
Mm-hmm.
Correct?
Okay.
Do you see what has happened to the graph?
Yeah, it's become like a small V. I mean, like
Yes.
almost a V at the
So
y axis.
let me go back a step. In fact,
Mm-hmm.
let me just release this from mod, because then you'll appreciate much better what has happened. Earlier
Okay.
this was the graph, and you see this part only, the one which I'm
Mm-hmm.
showing with my cursor, that part
Mm-hmm.
only gets reflected over here. Rest
Okay. Yeah.
all these parts are ignored.
Okay. Understood. Understood.
Understood? So y minus 1 is equal to 1 upon abs of x plus 4.
+4.
Okay, so I'll just
Okay.
remove the previous one now. Okay,
Understood. Okay.
abs.
Understood.
Okay, Now next is you're changing your x with x minus 3. So the same graph will appear to move 3 units to the right. So I'm making a change over here itself. So minus 3. As you can see, this part has moved slightly to the right.
Okay.
Okay. This change in curvature is so gentle that we don't actually observe it carefully.
Okay. Yeah.
Yeah. So if I try to zoom in a bit, so this is how it is.
Yeah. I basically just that part which got reflected on the negative side of the x-axis.
Yes.
Okay.
So now we'll move on to one more example.
Yeah.
Let's say I ask you to draw the graph of y is equal to 3 plus e to the power mod x plus 1 minus 3.
X plus 1 minus 3.
Mod of x plus 1 minus 3. Yeah.
Okay. It's fine. So first you will have to draw the. I think you can draw the graph of y equals x. I mean, y equals e to the power x. What am I saying?
Okay.
Yeah. Y equals e to the power x, and then after that, okay, you replace y equals e to the power x with e to the power x minus 3. So basically, what you're doing is you're shifting it 3 units to the right? And then you're shifting 3 units to the right, 3 units to the right, and you're also shifting it three units up because now you're taking y minus 3 into consideration. So y minus 3 equals e to the power x minus 3. So you're shifting it 3 units up.
Can we write down the sequence of events as you are doing it? So first step is what? First step you told you will be doing e to the power x. Perfect. Hello.
E to the power x minus 3.
Sorry, the voice broke actually in between. Yeah. What is the next step you're planning to do, Arushi?
Yeah, y equals e to the power x minus 3.
Okay, so you're planning to do y equal to x minus 3. Perfect. Nothing wrong in that.
Okay, then y minus 3 equals e to the power x minus 3.
Okay, absolutely fine. Then
3 units up. Then after that, oh yeah, now you mod the x value.
now we mod the x value.
Yeah.
Absolutely correct.
Okay, so when you mod it, it basically shifts. I mean, it reflects about the y-axis, like whatever's in the positive x part.
Right.
Then after that, you write
replace
x plus
x
1
with x with plus.
inside the modulus.
Yeah, you replace your x with x plus 1. That means you shift the graph 1 units to the left. Right?
Yeah.
So this is exponential graph that we can draw. This is just an exponential graph. This is shifting the graph 3 units to the right. Right? This is shifting the graph 3 units up. This is performing the modulus operation on x, mod just on x. So we know what goes in that operation. And then this is like shifting the graph 1 unit to the left. Correct?
Oh, yeah.
So let's try to plot the sequence of events on our GeoGebra.
Okay.
So let's move everything. We have y is equal to e to the power x first. So y is equal to e to the power of x first. Okay. Next is we are going to change x with x minus 3. So here itself I can make that change. X minus 3. So shifting the graph 3 units to the right.
Okay.
Then I'm going to change y with y minus 3, shifting the graph 3 units up.
Okay. And you put the modulus?
Yes. Next is you put the modulus on x. So it is y minus 3 is equal to
e to the
power mod absolute value of x minus 3.
Nice.
So this is the effect that will have on the graph. So whatever was on the positive x-axis, only that part got reflected to the negative side, and this line, as you can see,
Okay.
I am showing it with my cursor, this line vanished. Okay,
Yeah.
so it became like this.
Understood.
Correct. Now what are we going to do?
Yeah.
We are going to replace our x with x plus 1, meaning I am shifting the graph 1 unit to the left.
1 into the left.
So plus 1, so you can see this will move 1 unit to the left.
Okay, nice.
Understood the sequence of events?
Yeah, understood it.
Wonderful. Now we'll move on to the fact where we are again making certain changes in the graph.
Mm-hmm.
Let's say I tell you that we know the graph of y is equal to f of x. Okay?
Yeah.
And I need to know the graph of mod y equal to f of x. Now, try to understand, this is different from doing y equal to mod of x.
Okay, yeah.
Right? This and this thing are quite different from each other. How? Can you tell me how they are different? These two are different from each other.
Yeah. So if you have mod y equals f of x, then then you would have, okay, then y would be equal to f of x. Y would be equal to negative f of x. But then when you have y equals f of x, mod of f of x, then f of x equals negative y. So okay, so basically, um
Something,
yeah,
the screen
okay,
got
so
unshared. Just a second. Oh yes, screen shared.
okay.
Yeah. So just in the plain and simple words, just answer this
Mm-hmm.
question. In this expression, can my y be negative?
No, your y can't be negative.
No, Ashurushi, here y can be negative.
Oh, okay. No, wait. How? Oh no, the output can't be negative.
Output of it cannot be negative. F of x can be f of x cannot be negative.
Okay,
Okay.
fine.
Here f of x has to be positive.
Okay, so y can be negative and f of x has to be positive. Okay.
Yes. Yes, because you're comparing the modulus to something, so this will always be a positive quantity. So f of x can be always be positive. It has to be positive, but y can
Okay.
be negative because there's no restriction on y because mod is making it positive. So y can be negative as well.
Okay, understood. Okay,
But
so
in
y can be negative, but f of x that the output has to be positive.
yes,
But then for the other one, it's opposite.
it's
So
y
here,
has to be positive.
yeah.
Y has to be positive in this case, whereas f of x can be negative.
Okay, so y has to be positive, but f of x can be negative. Okay.
Understood the point? Okay. Now,
Yeah.
of course, since we have realized both are different cases, now how do I plot the graph of mod y equal to f of x? What should I do? Let's say I hypothetically give you a graph of y equal to f of x like this. Let's say my function graph is like this.
Mm-hmm.
Okay, let's say I have some sine waves over here. Okay, and here let's say I have some triangles being made.
Okay, just
Okay,
like
just a hypothetical graph. I've made up this graph on my own. Okay, now I just want to know what can I do to get the graph of mod y equal to f of x?
mod y equals f of x.
Yes, how would the graph of this be?
Okay, fine. So here y can be negative, but f of x has to be positive. So if f of x has to be positive, then would you keep the one on the positive side of the x-axis,
No,
no,
then
y-axis,
y,
y-axis?
positive side of y-axis, yes.
Yeah, the same, and simply reflect the ones on the negative side up.
Okay, so you're trying to say that I keep only these two,
Yeah,
okay, as per my given graph, and just reflect it down like this, right?
yeah.
That's absolutely brilliant. Wonderful. That's correct.
Okay.
See, again, since formally I explain it to you, just just for the purpose of recording it. See, when you
Mm-hmm.
say mod y equal to f of x, this can never be a negative quantity. This can never be a negative quantity. So you will never get these values. That means this part of the graph and this part of the graph can never be obtained.
Okay.
This
Yeah.
cannot be obtained.
Yeah.
Okay. Now, where f of x is positive, let's say I have these two graphs, and let's say here at x equal to 1, I get a value of 1, let's say. Okay. So this means you're saying mod y equal to 1, meaning y can take two values for the same x, which is plus and minus 1.
Yeah. Okay.
Right. So for the
Yeah.
same value, we will have a graph value down as well. So for all these values, we will start getting a value down as well. Are you getting this point?
Okay. Yeah.
That's
Understood.
how this actually gets reflected. This actually gets reflected about the x-axis like this, and that's how we get this structure.
Understood.
Okay.
Okay.
So the rule here
Got it.
whenever you are plotting the graph of mod y equal to f of x, so first thing is plot y equal to f of x without any restrictions on it.
Okay.
Secondly,
Then
reflect the graph.
let the one on the positive side be the same and simply reflect the other side about the x.
Yeah, you can introduce that step before writing this. Do not disturb the part which is already on the positive x-axis, positive y-axis.
Okay.
Do not disturb the part of the graph, which is already on the positive y-axis direction.
Mm-hmm.
And third step, reflect the graph which is on the positive y-axis about the x-axis, ignoring the part which was in the negative y-axis direction.
Okay. Understood.
Okay, great.
Yeah.
So let's do some questions based on this. Plot the graph of mod y plus 1 minus 2 is equal to uh, mod x square. I think I can write it without, yeah, just write it x square, because no book will write it as mod x square. So just x square uh, plus 3 mod x.
Plus 3 mod x.
Yeah.
Okay. Fine. So first, okay. So first, what you would do is that okay. 1 second. Okay, so first you can plot the normal quadratic equation. You can plot x squared plus 3x plus 2 without the modulus sign. So can I do that? Can I just bring plus to the other side and simply plot like that?
Can I write the sequence of steps?
What?
Can I write the sequence of steps that you are telling me?
Yeah. Okay. Okay, fine. So, fine. Okay, never mind. Can
First step is what you are saying, or
I was thinking that we could bring plus 2 to the other side and make it like a proper quadratic equation with x squared and plot x squared.
Okay. Okay. So first step is you are trying to
Yeah.
restructure this equation and write it as mod y plus 1 is equal to x square plus 3 mod x plus 2.
Yeah, and simply plot x squared plus 3x plus 2 without the mod.
Okay, so y is equal to x square plus 3x plus 2 without the mod. Okay, then?
Okay, so plot that first. Then after that, so once you plot it, and then x also has a modulus sign. So because x has a modulus sign, what happens is that it is reflected. The one in the after that.
So next you want to make a mod on x, right? That's what you're saying?
Yeah, yeah.
Okay. So it'll give you x square plus 3 mod x plus 2. Then?
Okay, so you do the reflection,
Mhm.
and then then you do the mod of y first.
Paper with the advanced group.
Huh?
Yeah, sorry.
Yeah, you do the mod of y. You so you would basically just reflect whatever's on the positive side of the y-axis to the you just reflect it about the
Okay,
x-axis.
so you're
So
just planning to do a
you
mod
do
on
mod
y,
y.
correct? This is what is the next
Yeah.
step, mod on y. Then what do you do? Just tell me what you're going to do.
Then simply shift.
How to do it? We know it, right? Then we shift it.
Yeah. So you shifted 1 unit to the left.
No, 1 unit down, right? Because you're changing your y with y plus 1.
Correct. 1 unit down.
Yeah. So this is how you get it. Very good. So this is fine. This you know what to do. This you know what to do. This you know what to do. So let's do this on our GeoGebra. So
Yeah.
that will be much faster. So first you said we'll plot y is equal to x square plus 3x plus 2, right? 3x plus 2.
Yeah.
Okay, so this is going to be a parabola like this. Then you
Correct.
said you're going to mod your x.
Yeah.
So here we'll mod our x.
X.
Okay.
Okay.
So the part of the graph which was on the positive direction, that only got reflected. The whole entire parabola over here got vanished.
Yeah. It almost looks like a straight line.
Almost, yeah, almost look like a beak kind of a figure. It's a beak.
Yeah.
Okay. Now you decided to take a mod on y.
Correct.
So let's say abs of y.
Mm-hmm. Mm-hmm.
Okay. So as you can see, the part of the graph which was above the x-axis, that graph got reflected below.
Okay. Yeah.
Okay. Because of some graphic issue, you'll see a breakage over here, but that's not a break actually. It's because of the graphic issue.
Okay.
Some pixels go missing actually. It's a heavy software, that's why it happens. Yeah. Okay.
Yeah.
Now it's proper.
Yeah.
Now next we plan to do y with y plus 1.
Yeah.
So we'll change this to y plus 1. So what will happen to the graph? It will shift 1 unit to the down.
Down.
Okay, as you can see, both the beaks have gone 1 unit down each.
Yeah.
Got the point? Now, is this a function?
Is this a function? If you take the no, actually,
It's
it's not.
not a function.
Yeah.
Mod y
Wait.
equal to f of x is not a function.
Yeah.
Is not a function. Because for any input of x, right?
Two.
Let's say this answer comes out to be 5. Then you are saying mod y equal to 5, implying y can be 5 also, y can be minus 5 also. So
Yeah.
this will not be a function.
Okay. Fine.
Okay.
Got it.
Chalo, now we'll move on to another special function which is called the greatest integer function. The greatest integer function. One of the most important functions that you would deal with.
Mm-hmm.
Also called as the floor function. Also called as the step function.
Floor or step function.
Yeah. Okay. I would abbreviate it as GIF always.
Okay.
GIF means greatest integer function. First of all, what is this function all about? Let's understand the definition of this function. So let's say when you say f of x is the greatest integer function of x, it is first of all represented by a square bracket like this. Okay. Now that doesn't mean any square bracket that you will come across is a representation for GIF. There in the question you would be given specifically where this represents
GIF.
the greatest integer function. They will not probably use the GIF short form. They will write the whole thing. Okay.
Mm-hmm.
Because many people will not understand what is GIF. They will confuse it with the GIF that we put on Facebook and WhatsApp. Okay. So this, what does it mean? This means this function will return to you the, this f of x will return to you the greatest integer lesser than or equal to whatever input you have put inside. So if you have put inside x, then it will return you the greatest integer lesser than or equal to x. So if I ask you what is the GIF of 5.34
The greatest integer lesser than
or equal to 5.34, what is the greatest integer lesser than or equal to 5.34?
5.
5. It cannot be
Yeah.
equal to, of course, because no integer can be equal to a fraction like this.
Yeah. Correct. So it's 5.
Yeah, 5. So if I ask you what's the GIF of 4.37?
4.37 will be 4.
Absolutely. What's the GIF of minus 6.24?
Okay, the greatest integer, it's the greatest integer lesser than that, right? So it would be -7.
Absolutely correct. This is a
Minus,
mistake which many people do. They think it's minus 6. It's not minus 6, it's minus 7, as you rightly said. What's the
yeah,
GIF of minus 0.000024?
zero, minus 0.0004. Okay, so that would be is it going to be, wait, so minus 0.00024, so that is, after final, the great integer lesser than that. So value lesser than that would be, would be it should be an integer. Okay, so is it, wait, is it minus 0.0, no, is it just minus 0? I mean, is it just -1?
Minus 1, absolutely correct. Okay, now you have known the definition of this. Can you plot the graph for this?
Yeah.
Let's say I give you a free hand.
Okay.
Now try plotting the graph of this and tell me what you
Okay.
see in the graph.
Okay. The graph of f of x equals uh, GIF of x.
Yes, yes, yes.
That one?
Yes.
Okay. So, hmm. 1 second.
Mm-hmm. So let's say I just ask you what is the graph for all values between 0 and 1, not including 1.
Yeah, for all values between 0 and 1, not including the graph.
Mm-hmm.
For all values between 0 and 1, not including 1. Okay. So if it's between 0 and 1, not including 1, then at 1 it will be at 1, at 0.5 it would be at 1, at, okay, so it's sort of like a
I want you to tell
straight
me
line-ish.
what would you see when you are dealing with such values which are between 0 and 1, not including 1. Can you see you'll always get a 0 for that?
Okay, well, okay,
Yeah.
between
So can I say the graph
yeah.
will be just a straight line like this and there would be a hole over here?
Oh, okay, fine.
Okay.
Yeah.
Okay.
Okay. So
The
okay.
whole signifies that you have not reached 1 yet. You are just before 1. Let's say
Yeah.
0.9999999. You have stopped there. Okay.
Yeah.
Okay. Now tell me what happens if you take the interval 1 to 2, not including 2.
1 to 2, not including 2. So that will be that whole graph will be at y=1.
Yes. So can I say it will be a line like this till you reach 2 value, and at 2 there again will be a hole.
Yeah.
All right.
I've seen this sort of thing somewhere.
Yeah. And if this trend continues, you'll see this kind of graph coming about.
Yeah.
Okay. There's this down also will continue like this. What does this give you a feeling about? It gives you a feeling of a step, isn't it?
Yeah. Step.
And that's precisely why this function is also called
Step
step
function.
function.
Yeah.
Okay. Now I'll also tell you why it is called floor function with some other example. Is that
Okay.
fine? Is that fine, Arushi? This graph is clear to you?
Yeah. Yeah.
Okay. So can you plot the graph for y is equal to GIF of x plus 2 minus 4?
Okay. X+2 minus 4.
Hmm.
Fine. So if you simply have y equals x, or y equals that square bracket of x, then what would you have? Yeah, you basically simply get the graph here, and x+2, meaning you're going to shift it 2 units to the left, so it gets shifted
Mhm.
2 units to the left, and then y+4, so it gets shifted 4 units down. So yeah, it gets shifted 4 units down.
So you're ready with that framework in your mind?
Yeah,
Okay, so can we draw it on GeoGebra?
yeah.
All right, so first of all, we'll draw the graph of y is equal to GIF of x. And in the app also, it is called as floor only.
Oh, okay.
Okay. But
Okay.
remember, in the app, it will not show you those holes because it is just a pixel missing for the graph.
Okay, understood.
Okay.
Yeah.
So what I'll do next is I'll replace my x with what was my function?
X with
X
x
plus
plus 2.
x plus 2, right?
Yeah.
So I'll replace my x with x plus 2 here. X plus 2. So as you can see, the graph will shift 2 units to the left.
Yeah, to
Correct.
left.
See that?
Yeah, yeah.
It is shifting 2 units to the left.
Yeah.
Okay. Next, the graph was requiring me to do what are the other operation that we are supposed to do on this? Minus 4. That means y plus 4.
Yeah, so it'll shift 4 units down.
4 units down. So I'm changing it here only y plus 4. Shift it 4 units down. Okay. As you can see, it is happening like this.
Okay.
Okay.
It shifted 4 units down.
Yes.
What is that like? It's that.
It's again a fault of the graphics. So
Oh, but it's not like that,
that's
right? It's
it's
only
not
like
like
flat, flat.
yeah, yes. It's not like that. This graphic sometimes starts showing you different versions. Okay. Anyways, so the moral of the story is all the transformations that we have studied so far would apply on this.
Yeah.
So we'll start with y is equal to GIF of x.
Mm-hmm.
Okay. Second step is y is equal to GIF of x plus 2 means shifting the graph 2 units to the left.
And then
Then
4 units down.
then we are doing this. That means we are shifting the graph in step 2 by 4 units down.
Yeah.
Okay.
Yeah. Understood.
Okay. Now the problem comes if we start plotting the GIF of a non-linear function. For example, if I say plot
What?
y is equal to GIF of x square, how would you do this?
Okay. Dot GIF of x squared. Okay, y equals that. So, okay, 1 second. 0. Okay. Uh, is it like so if you put in the value of 1, so it'll be I have to find out the greatest integer value that
Mm-hmm.
is lesser than or equal to 1. So it'll be a line along the x-axis. Then if I put in the value of 2, it'll be values uh, of x that is like lesser than 4. So
Mm-hmm.
less so it'll be in the interval between 3 and 4. So
Okay, now
right.
let's discuss this first. In this case,
Okay.
what is going to happen?
Hmm.
First of all, let's draw the graph of x square without any restrictions on it. So this is the graph of x square,
Okay.
let's say.
Yeah.
Okay.
Hmm.
Now what is happening? This value is 0.
Yeah.
Where do you think will attain a value of 1? So you'll say it's very simple. It will attain a value of 1 at 1, correct?
Correct.
Okay. So when you are looking at this part of the graph, when you are between 0 to 1,
Hmm.
you know your x square is also lying somewhere between 0 to 1,
Yeah.
correct? So
Yes.
what I'm going to write it here itself. So when you're looking at the interval 0 to 1, your x square is also lying in the interval 0 to 1, correct?
Yeah.
So when you take a GIF of such functions which are between 0 to 1, what will GIF do to it? It will straight away bring it down like this.
Yeah. Correct.
And there'll be a hole over here,
Yeah.
correct? Because for all these values, your GIF of x square is going to be 0.
Okay.
Understood? Is this part understood,
Understood.
Arushi? This is slightly tricky. See, between 0 to 1, your x square is also lying between 0 to 1. Yes or no?
Correct. X is also like, yeah.
So any value which is lying between 0 to 1, not including 1, will always have its GIF as 0.
Correct.
Correct.
Which the same thing with the previous one, right?
Okay.
Yeah.
Now
With the
ask,
GIF of x.
yes, same thing as that. Now ask yourself,
Yeah.
when will it attain a value of 2?
When will
What
it attain a value of 2?
what will be this value of x be here?
Okay. If so
For what value of
when okay, so
x,
it'll be
y will become 2?
okay when x is plus or minus root 2.
Root 2. Let's say positive only I take. Negative side I will also deal separately. Okay. Okay. Now see here. In this part of the graph, when you are between 1 and root 2, your x
Yeah.
square actually happens to lie between 1 and 2, right?
Oh, yeah.
So when you are in this zone, your y is between 1 to 2. So what will be the
Okay.
GIF of the function which is lying between 1 to 2? Won't it be just 1? Any value take between 1 and
Yeah.
2,
Okay.
not
Yeah.
including
Correct.
2.
Okay.
So can I say this part over here,
It'll be at 1.
it will be at 1 like this. Again,
Yeah.
there would be a hole at 2 over here. Understood?
Yeah.
Can you guide me with the next
Okay.
step?
And so if it's like
So
yeah.
when is it 3?
So
Ask yourself.
the
When will,
next yeah for 3 it will be 3 equals x square. So x should be plus or minus root 3.
right?
So that will be there plus or minus root 3. So basically when x is okay when x is between root 2 and root 3,
Mm-hmm.
x square is between 2 and 3.
Mm-hmm.
So
Including
the
2, not
smallest
including
value
3. Yeah. Be
the
careful
smallest
about
value I mean so okay the GIF of x square should be 2.
2. Yeah. So what will happen to this part of the graph? It will fall on like
2
this. Are you getting this?
and whole 3.
Okay. Do you see this trend happening?
Yeah.
Okay. Now, if you continue on the other side also, it will try to replicate the same thing because ultimately it's going to be a kind of even function. So the
Yeah.
same
Okay.
trend will be continued like this. Okay. So if I show you the graph
Oh,
on GeoGebra, this is how it happens. It's a very cool graph. So let's say
yeah.
y is equal to x square. I'll just show you first. Okay. Okay. Now see what is going to happen. I'm just going to draw it here itself, just to show what is happening.
Nice.
Okay, see what is going to happen.
So,
Between 0 to 1, I'll again broaden it a bit so that 1 is shown. Yeah.
yeah.
Now between 0 and 1, between 0 and this part of the graph will fall on the x-axis like this.
Yeah.
Correct?
Yeah.
Between 1 to root 2 will be somewhere over here. Okay.
1.4 something.
Yeah, that part will fall like this. I'll just type in root 2 for you here. So, or I'll do one thing. I'll plot y equal to 1, y equal to 2, y equal to 3, y equal to 4, like this. Okay, now see what is going to happen. This makes my
Okay.
life pretty easy. So this part of the graph, which I'm showing you with the red part,
Mm-hmm.
this part, this will fall on the orange part. Similarly,
Yeah.
like just how this part actually fall like this.
Yeah.
Okay. Similarly, this part will fall like this. That means vertically down there will be a arrow like this.
Yeah.
Correct. This
Correct.
part, again I'm showing you, this part
Fall
will,
on.
yeah, will fall like this, right?
Side.
And the same thing will happen on this side as well. So this part will be like this.
Mm-hmm.
This red part has
Fall.
this red part will fall like this,
Okay.
and this red part will fall like this, and it continues on and on.
Mm-hmm.
Okay. So do you really want to see the graph now? Okay,
Yeah.
let's show you the graph of this. Okay, so I'll just remove this line. I'll bring it back when time is there.
Mm-hmm. So
Y is equal to abs of.
perhaps floor.
Oh, I'm sorry. Thank you for correcting. That's floor. Floor of x square. You see
Yeah.
that? Do you see that? If I remove this, this is what you're going to see.
Oh, nice.
Okay. Now there's a trick over here. If you see, these lines will hide those ladders or steps.
Correct.
Okay. So what we normally suggest is a simple rule which I'm going to discuss with you.
Hmm?
The rule is, whenever you are asked to draw the GIF of any function, let's say
Okay.
let's say the graph of this is known to us. This is known to us. Okay.
Hmm.
And you're asked to plot the graph of this function. Okay. Where again I should, as a customary thing, I should write this is GIF, because any square bracket doesn't mean GIF. Unless until stated, don't treat any bracket as GIF. Okay.
Okay.
Then
Yeah.
what do we do is, we first draw the graph of that function. Let me just take a hypothetical case. So let's say this was the graph of your function. Okay. Correct.
Hmm?
Let's say
Yeah.
f of x graph is like this. Okay. Now what do is, you make
Yeah.
lines at a unit distance like this: y equal to 1, y equal to 2, y equal to 3, y equal to
Okay.
4. If the graph is going down also, let's say I take a graph like this down. Okay. Then you have to make it at y equal to 0 is already made, y equal to -1 you have to make, y equal to -2 you have to make. Let's say, suppose this many intervals. Then what do?
Okay.
You start bringing this part. Let's say this part will fall like this.
Yeah.
Okay. So it is
Okay.
falling on the floor. Think as if it is falling on the floor, and hence it is getting the name of floor function.
Floor function.
Yeah,
Okay. Got it.
because all these graphs starts falling on the floor. Think as if this is the next floor. Okay. This graph will fall like this. This graph
Okay.
will fall like this. Understood?
Yeah, understood. Okay.
So this is the
Simply
graph.
the line's unit distance and use that for reference to put your.
Absolutely, absolutely. So just start plotting the lines which are at a distance of 1 1 each, and start making the part which is sandwiched between the two lines fall on the floor below it.
Okay. Yeah.
Understood how it works?
Got it.
Chalo. So I'll give you some questions.
Okay.
Plot the graph of y is equal to x minus 2 whole cube floor of this
Mm-hmm.
plus 1, and let's say mod on y. Try to include everything that we have studied so far.
Okay. Mod of y.
Should I do mod on x also? No, it's fine.
Okay.
You just draw this. In fact, you just try without mod. We'll try to see what happens, after we have done this. Yeah, first draw this. Let's learn step by step.
Fine. So first, okay. So first, what I'm going to do is y equals x the GIF of x minus 2 whole cube plus 1. So first we draw x cube, then shift x cube 2 units to the right and 1 unit up. So
Mm-hmm.
okay, so we x minus 2 whole cube. So 2 units to the right. Then y you replace with y minus 1 equals x minus 2 whole cube. So what's that going to be? You have to then you're going to move it to 1 unit up. So 2 units right, 1 unit up. Then after that, I have to take the
But you are replacing your y with y minus 1 without taking the GIF on the function.
Yeah, correct. So
But
that's
after
not
that, if you
the step you do first.
but after that, if you take GIF, then it will be including 1 also within the GIF bracket. So that may become wrong.
Yeah. So that's why I think yeah. So you don't shift across y-axis. You simply first do you shift the x by x minus x cubed by 2 units to the right.
That's fine.
And then you take the GIF.
Absolutely, absolutely. Then you have to take GIF. Correct, correct.
So then you take GIF that. So you so what will that be? So if so when x so first you take when x is when x is between 0 and 1.
No, you just have to follow the method which I discussed with you.
Okay, it's simply okay. You first
Once the rule is discussed, follow the rule. Don't have to do it from the basics.
okay.
So
So
first is
you
this step, right?
simply draw.
Let's write it, Rushi, what you are planning to do. First is this step, correct? If I'm not wrong.
Yeah.
Then is this step, if I'm not wrong.
Correct. And then the GIF step.
Then is the GIF step, if I'm not wrong.
Yeah.
And then you're planning to do y with y minus 1, correct?
Correct.
That's how we get to our graph. Okay.
Yeah.
Absolutely correct. Let's plot it on the GeoGebra and see what is the chain of events.
Okay.
Since it is cluttered, I will go to and open a new GeoGebra tab. Have you started using it in your at your home?
Yeah. I started using it.
Okay, so y is equal to x cube. This is the graph. Okay, undoubtedly. Now next is y is equal to
x minus 2.
X minus 2 whole cube. So this gets shifted by 1 unit to the
2 units to the right.
2 units to the right, correct?
Yeah.
Then we have to do the GIF of this, correct? So GIF is floor of x minus 2 the whole cube. You see that? Okay.
Yeah.
And again, this can be very easily be drawn if you just start making lines like this. If you just make lines y equal to 1, y equal to 2, etc. So I'll just minimize this. Yeah. So if you make if you start making lines like this, 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 this,
And
this,
down.
this, and start making them fall on the floor next to it. For example, this guy will fall like this.
Yeah.
This fellow will fall like this. This fellow will fall like this. So the ladder length would become smaller and smaller.
Yeah.
Okay, it will start falling like this. Okay, so that is how you get the graph for this. Got it?
Okay. Fine.
Got it?
Understood.
Okay. Next, what you do is you replace your y with y minus
1.
1.
1 minus 1. Yeah.
Okay. So y minus 1 means you're shifting the whole thing 1 unit up.
Yeah.
Okay?
1 unit up.
So minus 1, see how it will move up.
Okay.
And
Fine.
the distortion is because of the graphic issue. Okay.
Okay. So it simply moves up. Okay.
Yeah. Is that fine? So the vertical lines that you see, they will not be there. It is just because of the graphic issue.
Okay.
We will try one more question. What if I take a mod on y? What will happen? Just tell me what will happen if I take a mod on y.
Okay, if you take a mod on y, then so it will
Whatever
the
was
positive side of it will the one on the positive side of the y-axis will remain the same, but then it will remain the same, but then it'll also get reflected about the x-axis down.
x-axis down. Very good, very good. Let's just try to plot this again. Okay, so we have abs y minus 1 is equal to floor x minus 2 the whole cube. See the graph.
Cube. Yeah.
You see this?
Correct. Okay.
Okay.
Yeah.
So this is the graph that you'll see.
Okay.
Okay.
So simply got reflected.
Simply got reflected about the x-axis, and the negative part was removed. Okay. Try this one.
Okay.
Y is equal to plot y is equal to GIF of 1 by mod x minus 1 plus 3, okay, minus 2.
Minus 2. Okay.
Let me just put this entire thing under mod.
Whole thing.
Whole thing under mod, yeah.
Okay. So first, you would just okay. So first, the basic graph is going to be y equals 1 by x.
Absolutely correct.
Then if it's y equals 1 by x, then after that you shift it. You shift x by 3 units. So so x is replaced by x plus 3. So you shifted 3 units to the shifted 3 units to the left. Yeah, 3 units to the left. Units left. Okay. Then after that, x is then you mod x.
Beautiful.
You find the absolute value of x plus 3. Okay, so when that is done, what happens?
You know what happens. Okay, that's fine. We'll leave it to the graph.
Yeah.
Now what is the next step?
So then after that, you replace x with x minus 1 again.
Absolutely.
So you shift it
1 is to the right.
Yeah.
Then
so once you have that, wait. 1 second. So you do that. Okay. Yeah. Now you take the value, the GIF of this thing.
Absolutely.
Okay. Take the GIF of that.
Okay, and you know what to do in that. You just have to make lines, parallel lines. Okay, at one unit distance, and start making it fall on the floor. Yeah. Then.
Right. Then after that, this is okay. So this thing is shifted. It shifted 2 units down.
Down. That means you are now doing this.
Yeah.
Very good.
2 units down.
Which is
Then
equivalent to saying
after that,
that you are sending this -2 on the other side. Oh, sorry, it was
yeah.
a +2. So -2 will come on the other side. Okay.
Okay. Now you do that. You shift it like two units down, and then after you take the modulus value of the whole thing.
That means whatever was below the x-axis, you send it above, right? And whatever was already above, you don't disturb
No,
it.
correct. Yeah, because it's modulus of f of x. Yeah.
Absolutely, that's perfectly. Roadmap is perfect. So let's try it out on GeoGebra first. I
Okay.
will just plot it on the GeoGebra.
Mm-hmm.
So first step is we are going to plot y is equal to, just follow the changes that happen to the graph. Okay.
Yeah.
So y is equal to 1 upon x. This is fine.
Yeah.
Then y is equal to 1 upon x plus 3. So I'm just going to make a change over here.
Mm-hmm.
X plus 3. Okay, shifted 3 units to the left.
Yeah.
Then you're just modding x. So
Okay.
it's y is equal to 1 upon
Mod
absolute
x.
x plus 3.
Yeah.
Okay. As you can see, only this part of the line, which was below the, oh, why did I write to +2? It's plus 3.
Plus 3.
Yeah. So this part of the line only gets reflected over here and the blue one
Mm-hmm.
disappears. Okay.
Then
Next,
x
replace your x with x minus
plus
1.
1.
Means you're shifting this 1 unit to the
That's
right.
fine.
As you can see, 1 unit to the
Yeah.
right.
Yeah.
Okay. Then what do? We take the GIF of the whole thing, correct?
Yeah.
So we can say y is equal to GIF, which is floor of Q. Okay. Everything falls on the floor because
Mm-hmm.
it is below the one line.
Oh, correct.
Okay.
Yeah.
And now
Yeah.
you're doing what? You are taking -2 on this, right?
Yeah. Minus 2.
So you will be doing y is equal to r function -2. As you can see, it has come down by 2, correct?
Yeah.
And then you're
Yeah. Okay.
doing y is equal to abs of whatever function you have got, which is s in this case. So it'll go 2 units up. So it'll be a straight line y equal to 2. So much we did just to get a
Wow.
straight line. So this is your,
Straight line y equals 2.
this is the straight line y equal to 2. Is that fine?
Okay. Good.
Let's now
Nice.
let's now introduce you to a next important special function, which we call as the
Mm-hmm.
fractional part function.
Fractional part function.
Acha, just a question before we go to the fractional part.
Mm-hmm.
What if I ask you to plot the graph of x is equal to GIF of y?
Okay. So first and foremost, just use our inverse function concept, right?
Absolutely, very good. So first we start with this.
Yeah, y equals absolute in the GIF of x, and then simply reflect it about y equals x-axis.
Reflect about y equal to x line. Absolutely correct. So can we see how it looks? It look
Okay.
a floor in the vertical direction.
Yeah.
So since this is already cluttered, I will open a new page.
Mm-hmm.
So x equal to floor of y.
Yeah.
Okay.
Okay.
It's not going to the vertical way. Ignore the horizontal lines.
Yeah. Simply this one. Okay, got it.
Okay.
Yeah.
Acha, let's say if I want to draw x equal to GIF of y square minus 3y plus 2.
Mm-hmm.
How will I do this?
Yeah. First, you would simply plot y equals x squared minus 3x plus 2.
Okay.
Then you would get the GIF of that. Minus
Okay.
3x plus 2. You get a GIF of that.
Mm-hmm.
Then you reflect it about y equals x line.
Absolutely. Absolutely. Good. Achha, just a final question.
Mm-hmm.
What if I do the GIF on both?
Okay. But if you do the GIF on both,
Hmm.
so okay, GIF of y equals GIF of x. So basically, if I put in like a value of x as one, no, as I don't know, maybe like 1.5,
Mhm.
then the GIF of that would be at 2, right? So 2 will be 2. That'll give you GIF of x will give you 2, but then I have to find out. So 2 equals GIF of y. Wait. 2 equals GIF of y. So if 2 equals GIF of y, it'll be like a line. Um, 2 equals GIF of y. Be a line between the values of 2 and 3. Will it?
Mm,
Like be a line between 2 and 3?
think again carefully. I mean, can I say if x is between 0 to 1, y should also be between 0 to 1?
Yeah. Okay. Yeah. Fine. Okay.
So let's focus on this box 0 to 1 and 0 to 1.
Okay.
In this zone,
Mm-hmm.
if I take any point, let's say I take this point,
Okay.
x will be somewhere between 0 to 1.
Yeah.
Y will be also between somewhere between 0 to 1. So can I say their GIF would be equal?
Okay, the GFs would be equal.
So can I
Okay.
say it will be valid for any point which lies in this box excluding the tip?
So their GIFs are equal. Okay, fine.
For example, if I take a point on the tip over here
Mm-hmm.
GIF of x will be 0, but GIF of y will be 1. So excluding the tip, all the point would be included. Excluding the
Yeah.
tip means excluding the corner. I'm shading it with white. Okay. So this white is excluded from this box.
Okay.
Okay.
Mm-hmm.
And can I say the same thing would be true even if I make a box like this?
Mm-hmm.
Now, excluding the box itself, excluding the edges of the box itself, if I take any point like this, let's say this point is 1.7 comma 1.6.
Okay.
Can I say GIF of x and GIF of y would also be equal?
GIF of X and GIF of Y will also be equal. Okay.
Yeah. So
Okay. Yeah.
can I say for every point within this box, again excluding the edges of the box, this condition would be satisfied?
Okay.
And actually this continues on, and you'll start getting not a graph per se but an area which will satisfy this.
Okay. Oh, can we see it in GeoGebra once?
GeoGebra actually doesn't show this, but let's try it out.
Okay.
Let's say floor x is equal to floor y. It doesn't show the complete region actually, it shows you the line. It's actually
Yeah.
a shaded
That's
area.
fine.
It's actually a shaded area.
Okay.
It's actually boxes like this.
Floor Y. Okay. Yeah.
Yeah,
Okay. Yeah.
this entire box will be your answer.
Mm-hmm.
This entire box will be your answer, except the edges of the box. I cannot choose a point on the edge. For example, if I choose this point, what will happen here? X is 1, but y is, let's say, 0.5.
Mm-hmm.
Correct. So GIF of 1 and GIF of 0.5, they're not equal, right?
Yeah.
So these points will not be in my list. Similarly, if I
Okay.
choose a point here, let's say 0.2 comma 1.
0.2, 1.
So GIF of 0.2 is not equal to GIF of 1, correct? So this point will also be not included. So on the edges of this box, the points lying on the edges will not be included. Just
Mm-hmm.
one within the box will be included.
Okay.
Okay.
Got it.
Okay. So there was a question in IIT JEE where they asked to calculate the area bounded by this curve, okay, from some value of x to some value of x. For example, 0 to 4. So what is the
0 to 4.
area bounded
Okay.
by this curve from 0 to 4? So as you can see, in 0 to 4,
4 unit square.
you'll have 4 squares. Yes.
Yeah. 4 unit square.
So 4 unit square would be the answer. Okay.
Yeah.
So now we'll move on to
Okay.
the fractional part function.
Okay. So basically, one second. Can you
Yeah.
back? I just need to that part once. just the previous.
This one?
Yeah. Okay. So basically, the whole box underneath, bounded by those two lines, will be equal. Like the whole. Oh. Okay.
This would be your area, but not including the surface, periphery of the box.
Okay. That is because the GIF of x should be in that area. The GIF of x is equal to the GIF of y.
Yeah,
That's
but
why it comes.
not on the edges, not on the edges,
Not on the edges.
not
Okay.
on the edges.
Fine. Okay.
Maybe in the this edge it will be.
Mm-hmm.
Maybe on this edge it will be, because if I take a value here, y is always 0, right?
Yeah.
So 0.2 comma 0, the GIF of 0.2 and GIF of 0 would be same, but
Okay.
it would not be on these two edges. These two edges will not be included.
Hmm.
Okay, but these two
Understood.
edges you can include. These two edges you can include.
Mm-hmm. Understood.
Okay.
Yeah.
Yeah. So fractional part of x.
Hmm.
So fractional part function. Fractional part function is a function which is represented by curly brackets. So whoever fractional part you require, you feed it as an input to it. So let's say I take a very simplest of all cases where I find the fractional part of x.
Mm-hmm.
So what does it return? By definition of this function returns. The function is a machine. You put some input and it'll return you something, correct?
Yeah.
So it returns x minus GIF of x.
Okay. Fine.
Okay. So you can treat fractional part of x to be just x minus GIF of x.
Okay.
So for example, if I ask, what is the fractional part of 7.2?
Fractional part of 7.2. So it'll be 7.2 minus 7. Okay, it's 0.2.
Yeah, so 0.2 is the fraction part, correct? What's
Oh,
the fractional part of 8.867?
0.867.
0.867. What is the fractional part of negative 2.36?
Negative 2.36.
No.
Okay. No. I'm just saying it out to myself.
Okay.
So negative 2.36 will be negative 2.36 minus the fractional. I mean the what's that? The GIF of this. So the smallest integer. I mean, yeah. The greatest integer fraction. Will be, yeah. Correct. Okay, fine. It'll be 1 second.
Mhm.
1 second. Lesser than or equal to x. Okay, so lesser than that would be so it would be minus 2.36 minus of minus 3.
Mhm.
So minus of minus 3. So 3 minus 2.36.
Mhm. That's 0.64.
Yeah. Okay. Yeah. 0.64.
Absolutely correct. Now, given that you know this definition, can you plot for me the graph of fractional part of x? Again, any curly brackets, please do not treat it as a fractional part unless until stated. Yes. So the question will say this represents the fractional part of the x. This represents the fractional part of the function.
Okay.
So tell me, how would the graph look like?
So if at 1, 2, 3, and 4, it would be at 0.
Yeah, start looking at intervals as you rightly approached. Start looking at what happens between 0 to 1, what happens between 1 to 2, what happens between 1 to 3, what happens between 0 and minus 1. If you find for these intervals, you'll know the trend of the graph.
Yeah. So but at 1, 2, 3, and 4, it'll be at 0, right? And then
Yes.
so between 0 and 1, what would be there? Okay. So if you take 0.5,
So let's
then
say I am between 0 and 1. Then what will happen to the fractional part of x? What will it return to me?
So if you take 0.5 for example, so 0.5 minus 0. So
It will be 0.5 only.
Yeah, so it'll return 0.5 if
Right.
it's 0.5.
Right.
So it will basically just return that between 0 and 1, it'll basically just return the value of x.
Absolutely. So you got the answer. So from 0 to 1, can I say it will be just be a part of the line y equal to x?
Yeah.
Okay, this is just a part of line y equal to x, just a small part. Okay.
Oh,
And
okay.
exactly at 1, as you rightly pointed out, this should fall down to 0. It should come over here.
Yeah.
Correct. So there will be a hole left over here.
Correct. Got it.
Very good. Now try from between 1 to 2.
Between 1 and 2, okay. Okay, 1 second. Between 1 and 2, okay, add 2 again, it comes to 0. But if you say 1.5, for example, 1.5 minus 1.5 minus 1 is 0.5. Okay.
If you take 1.7 also, it will give you 1.7 minus 1. If you take 1.9 also, it will give you 1.9 minus 1. So in general, can I say it is giving you x minus 1?
Yeah. Okay. Yeah.
So isn't
X minus 1.
x, so isn't x minus 1 is basically a line y equal to x minus 1, means the same line shifted 1 unit to the right.
Oh, nice. Okay. Yeah.
So now it will appear like this.
Okay.
And if you follow the trend, it will keep on going like this.
Okay. Nice. Nice.
Okay. So this will be the graph of GIF. What will be the tip be at, or what is the value that it try to approach here at the tip? That's
Try to approach
1.
1.
But it will never become 1. It will be 0.999999999, but it will never be able to get 1 value.
Oh, never touch 1.
Never touch 1. Absolutely.
Is it almost like an asymptote? Can you say that?
You cannot say asymptote. These values are not achievable.
Okay, achievable. Okay. So never reach it. Okay.
Yeah, never reach it. So let's say I want to plot it on GeoGebra. So it will be y is equal to x minus floor x. There's no direct function for fractional part actually. Yeah. As you can see, this is the line that you get. See. Again, those holes, the graph will never show you.
Yeah. Okay, understood.
Understood? Okay. So now let's ask you some questions. Please plot the graph of hmm, uh, fractional part of x plus 2 minus 3.
X plus 2 minus 3. Okay, fractional part of x plus 2 minus 3. Okay. So first, 1 second. Okay. So the first I'll have to plot date. Okay. So this first I can plot the fraction part of x plus 2. Okay, if I need to plot the fractional part of x plus 2, is going to be x plus 2 minus GIF of x plus 2. Plus 2 minus.
First, you'll plot this graph, right?
Okay, fine. Okay, so you first plot that, then you shift it to the
Left by 2 units.
by 2 units.
Then
you shift it down by 3 units.
Absolutely done.
Yeah.
Then you do y plus 3 equal to this. So you shift it down by 3 units.
Understood.
So let's check on GeoGebra again. So y is equal to y is equal to y is equal to, so my f is already a fractional part. Okay, so fractional part minus 2 you want. No, here the function is slightly different, so again I'll write it, no worries. So fractional part of
x plus 2 minus fractional part of, no, and then minus x plus 2 minus GIF of x plus 2.
the function was function part of x plus 2.
Yeah.
So you write x plus 2 x plus 2
minus
minus floor
of x plus 2.
x plus 2. As you can see, the graph has got
Two.
shifted units to units right, but you don't see an change in the graph because
It's
whatever
all
was
same.
whatever was occupied 2 units to the right, the same moved 2 units to the left. So the graph doesn't make a difference. Okay.
Yeah.
Now you change your y with
Oh yeah, with y plus 3.
y
So
plus 3. It will go up.
yeah, then
No, we change your y with y plus 3, right? So
yeah,
for us, it has to be from
down.
here. I have to be g minus 3. I have to write.
Oh, that's right. Okay.
So the graph will go 3 units down.
Okay,
Is
got
that
it.
fine?
Mm-hmm.
Okay. Let's do another one. Do this very, very carefully. Okay.
Mm-hmm.
Y is equal to under root of
Okay.
GIF of x. Okay.
Mm-hmm.
Plus greatest integer of x. Okay.
Plus greatest integer of x.
Yeah. I'll be back in 1 minute. Okay.
Yeah.
Just try this. Any idea how to do it?
1 second. I'm still doing it.
First, ask yourself whether you know this graph or not. Root x graph.
Okay, that's x to the power half.
Yeah, it'll actually be this. I already told you y square is equal to x. It has two graphs for it. Y equal to root x.
Y minus root x.
Minus root x. So this part is y equal to root x, and the part which is below like this
is okay.
Y is equal to negative root x. So I just need the upper part. So I just need this part of the graph.
Okay. Oh, okay, yeah.
That would be helpful for you in plotting this.
Okay. Just the upper part of the graph. Okay, so first, wait. Okay, so first, do you plot y equals curly bracket of x, then hello?
Yes, I can hear you.
Do you first plot y equals curly bracket of x?
But how do we root this?
Okay, oh no, but first, okay, wait. Yeah. Wait 1 second. So y Okay, so first you plot y equals root x.
Y equal to root x.
Yeah.
Okay.
Then, okay. Then what? Okay, so after that, after you do y equals root x, then do you have to find out its no. Wait. Root x, then what? Okay, so that's gonna be y equals x to the power half. So okay.
Should I give you a hint? Work with intervals. First see what will happen between 0 to 1, then see what will happen between 1 to 2, like that. That would be more helpful.
Okay, first, okay, fine. So first, for the whole graph, do it for that. Okay, only for
you know the trend. Once you do 1 or 2 intervals, you'll know what is the trend of the graph.
Yeah.
So I'll help you with this. First try between 0 and 1. What will happen to this function?
Between 0 and 1. Okay, so
Let's say
if you take 0.5 for example,
I think you have already figured out that fraction part was just behaving as x, and this will be 0 only.
Okay.
Correct. So it is as good as just plotting root x graph only for this interval.
Okay, only for that interval. Okay.
Now what will happen when you are between 1 to 2?
1 to 2, basically it becomes x plus 1. Oh yeah, root of x minus 1? Yeah, correct, it becomes x minus 1.
Because
okay.
this thing is as good as saying root of x minus floor x.
Yeah, plus x, yeah.
Yeah, so basically between 1 and 2, x will remain x, nothing will happen to it. The floor x function will become a 1, right?
Yeah.
So x minus 1 root plus 1.
Okay, fine. So then after
now you
that,
know the trend. So what will happen after that? Let's say 2 to 3.
2 to 3. Okay, then it'll be x minus 2 plus 2.
Absolutely, very good. Then 3 to
then
4.
3 to 4 will be x minus 3 plus 3.
Okay, now enough evidence is there for us to plot the graph now. Let me start plotting the graph.
Okay.
So for 0 to 1, your graph will be just the graph of root x graph. So only this part I will draw.
Okay.
And I'll stop just before 0. Just before 1. So I'll put a hole.
Yeah.
So this graph is plotted.
Okay.
What about this graph? How do I plot y equal to root x minus 1 plus 1? Plus 1 means you are doing this.
Okay.
So can I say it is just the shifted version of this graph, 1 unit to the right and 1 unit up?
Yeah, so you simply shift it. Okay.
So this part only will shift 1 unit to the right and 1 unit up. So won't it appear like this?
Yeah. Okay.
But remember, the tail of the next one will fill the whole of the previous one. So there will not be any discontinuity here.
Okay, and then same thing for between 2 and 3.
Absolutely. Keep on going like this.
Okay. Yeah.
Are you getting it?
Right.
So it will be some kind of a cloud structure. Let's see.
Okay.
So our function was y is equal to under root of x minus floor
of x
to the power of 0.5
okay
plus
floor
x.
Floor x.
You see that?
Yeah. Okay. Yeah.
Now what will happen if I ask you plot the graph of I'll just make a slight change in the question.
Yeah.
Plot the graph of y is equal to under root of fractional part of mod x.
Fractional part of mod x.
GIF of fractional part of mod x.
Wow. Plus GIF of plus GIF of mod x.
Yeah.
Not fractional part. That's not fractional part, right?
No. It's the GIF of mod x. Did I say by mistake fractional part? Oh, sorry about that. So it's under root of fractional part of mod x plus GIF of mod x.
Okay, plus GIF of mod x. Okay, so first, okay, again deal with intervals.
You have already done 90% of the job. You're just replacing x with mod x, right? So what should I do with this graph which I've already obtained?
Correct. All you have to do is you have to simply reflect it. You have to reflect it about, yeah, you have to just you have to keep the positive side as it is and simply reflect it across the y-axis.
Correct. So it will become something like this.
Yeah.
Like Batman. Correct. So
Yeah.
if I show you here, so y is equal to p abs x. You see that?
And Batman.
Correct. And if I do a mod of p only, what will happen? Let's say I do y is equal to absolute value of the whole p of x function.
Okay.
It will slightly twist.
Yeah.
Because whatever was below will go up.
Yeah, I just reflected. Yeah.
Are you getting it?
Yeah, yeah.
So let's take a few more examples. Plot mod y minus 1 is equal to
mod y minus 1 equals
fractional part of
x
mod x plus 1 minus 3.
Minus 3. Okay, so first you have okay, so wait.
Once again, I'll just make it slightly easy because okay, let's do this one. Yeah, let's do this one. You already know how to do fractional part of x plus 1, correct?
Yeah.
You already know this?
Yeah.
Okay.
So
now my question is, if somebody asks you fractional part of any function, will you be able to plot it?
Fractional part of any function, yeah.
For example, if I say fractional part of x square minus 3x plus 2, will you be able to plot it?
Yeah. Okay, so you just first you plot x square minus 3x plus 2 and then you find out this fractional part. So basically, yeah. Okay. So what would you do? Yeah, so it would be so you would take it between different intervals and plot it that way. Okay, you first do between the interval of x and 1, you would do x square minus 3x plus 2, and between 1 and 2 it would be x minus 1 whole square minus 3 times x minus 1 plus 2. Does that make sense?
Write out. I just want to see how much you can think.
Okay. So okay, so am I going the right way?
What is the step that you're planning to do?
First do it between the interval of 0 and 1. Okay.
But in that case, calculating value for all the points would not be easy, right?
Okay.
See, I'll tell you a simpler way out. Let's say I want the graph of fractional part of this entire function. So first of all, I'll plot without it. So I'll just simply plot the graph of a parabola like this.
Okay. Okay.
Okay. Now see what is happening in this case. When you're doing a fractional part of x.
Okay. Fractional part of the whole thing.
What are you doing? You're trying to assign y some fractional some value which is between 0 and 1, isn't it?
Yeah. Correct. Between 0 and 1.
Yeah. So what are you doing actually?
Okay, so you're trying to assign it a value between the fractional part. You are trying to assign it a value between 0 and 1. So
if let's say this value was 5.24.
Yeah.
Right? And then when you're doing fractional part of this, then what are you actually trying to do? You're actually trying to do 5.24 minus 5, correct?
Yeah. So correct.
Okay.
So x square minus 3x plus 2 minus minus this one of that minus GIF of that.
So my take is, wherever is the point, you are actually bringing it down by the integer value at that position. For example, I'll just show you a simpler case here. Okay, let's say I draw these lines, y equal to 1, y equal to 2, and let's say y equal to 3. So any value here, any value in this zone, hope you can see the color. I'll change the color to blue. Any value in this zone, its value should be brought down by how many units? Let's say this value is 2.6. It should be brought down to 0.6.
Yeah, correct.
So can I say for this value of x, this graph will start falling over here like this?
Why? How?
Because you are bringing it down to 0 to 1 gap. Because this answer can never exceed 0 to 1. Fractional part of anything should always lie between 0 to 1.
Okay, fractional part of anything should
lie between 0 to 1. Yeah, it cannot be greater than 1. It cannot be equal to 1 also. It has to be somewhere between 0 to 1.
Right. Okay.
So what you're doing, every part you are bringing it down directly within the 0 to 1 block. So this fellow will fall down like this.
Okay, fine.
Correct. This fellow will fall down like this.
Okay.
Are you getting it? So it'll start falling like this, and you will be very surprised to see the actual graph also. So y is equal to, let's say I draw the function x square minus 3x plus 2. Okay, this is the function.
Yeah.
Now just see what I am going to do. Y is equal to c minus floor of c.
C minus floor of c.
C of x I have to write, I think. Do it. Let me open another one. So y is equal to x square minus 3x plus 2 minus floor of x square minus 3x plus 2. You see that?
Yeah. What is that?
Yeah, that's what I'm trying to explain over here. See, what is going to happen is minus 3x plus 2. What is happening is,
yeah.
Yeah. Yeah, see this part. What was happening is this part over here. I'll start with the shading of the graph. This part, this has fallen over here. So this is the response for it. Getting it?
Yeah. Wait, why is it fallen over there again?
Again, because this value is somewhere between, let's say this, I talk about this zone. It is somewhere between 2 to 3.
Correct.
So if I take any value like 2.7,
yeah,
it should have given me 0.7, correct? So this will fall by 2 units down over here.
Okay, fine.
So this point will drop at this point.
Okay, that should give you 2.7. The fractional part will be 0.7.
Yes.
So it's gonna fall
by 2 units down.
Okay.
So every point in this zone, Arushi is going to drop by 2 units down.
Okay.
So this guy will fall over here. This guy will fall over here. So like that, every point will start falling on this line. This.
Okay.
Okay.
Fine.
Are you getting it?
Yeah. Wait. It fall by 2 units because that was 2.7 and now it's become 0.7. So.
Right. So GIF of fractional part of 2.7 should be 0.7, right?
Yeah.
So it started falling 2 units down. Similarly, any point between 3 and 4 will start falling 3 units down. Correct?
Yeah. Okay.
So this guy will fall like this guy.
Okay.
Are you getting this point? So
Yeah.
the response on this green graph is your red graph
Okay.
that you see.
Okay.
So everything is fine here, but what will happen to this part? This is a negative already, right?
Yeah.
So remember the GIF function, if you are already dealing with a negative part. So let's say if I say GIF function, what will be the GIF function if you are already between -1 and 0?
Okay. So it'll be x.
So remember what we used to do? It's x minus this.
Yeah, it'll be x.
So
I
it'll
don't
be
know.
x
Yeah.
plus 1 then.
Yeah, x plus 1. Yeah. Okay.
Correct. That means every point here will get a jump of 1 up.
Oh.
So it has come over this point.
Okay. Fine. Understood.
Understood?
Yeah. Okay.
Very interesting graph. Correct.
Interesting.
Back to this. So this will start, making it like this, but it will become more cluttered towards the end because this graph is becoming more higher and higher.
Yeah. So okay.
Awesome. So one last question before we close the session.
Okay.
How would we draw the graph of, let's say the same thing now, the x has been replaced with fractional part of x.
Okay. So here y equals x squared minus 3x plus 2. Okay, so here x has been replaced by fractional part of x.
Yeah.
Okay, so if I first deal with x, then okay, so wait.
It's very simple. It's not as complicated as the previous one.
Okay, so if I take in a value like if I take in a value like 1.2, it'll bring it back. No, I'm getting confused.
Right.
I don't get this. Wait.
Okay. See what is going to happen.
Okay.
Without the GIF on x, the graph was like this, correct? I'm just going to draw a miniature version of the graph, correct?
Yeah.
Now, no matter whatever x you put to the function, your x will always be restricted between 0 and 1, right?
Yeah.
So whatever is the part of the graph between 0 to 1, the same graph will start repeating every time.
Okay.
Are you getting this point?
Okay.
Okay. Because whatever x value you put, let's say you put x value as 2.3, then fraction part of 2.3 will be just 0.3.
Yeah.
So at 2.3, let's say I take this as 2.3, it will draw the same graph as what it had drawn for 0.3.
Okay.
Are you getting this point?
Okay.
So it will start plotting the same part, which is, I'll show you over here. So now I have to plot y is equal to c of x minus floor x.
Okay.
It is not showing any response for this. I have to type it literally. Sometimes it irritates. So x minus floor x square minus 3 times x minus
Floor of x.
Floor of x
Plus 2.
You see that?
Okay. Yeah.
So,
Okay.
Whatever I said, the part of the graph which is between 0 to 1, this part is only repeated everywhere. Tuck, 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 whole side.
Okay.
Are you getting it? So the graph is closing its eye and only replicating this part everywhere because you are making a fractional part on x as your input to the function. So whatever it had drawn for 0 to 1 gap, whatever it has drawn for this gap, it will start replicating it everywhere.
Okay. So, okay. Fine. Okay.
Cool. Understood this?
Yeah, okay, fine.
Okay.
Thanks.
Now, before we sign off, I'll leave you with a question.
Okay.
So we already learned how to. I'll give you 1 second, beta. 1 second, I'll come back. I don't have with me. You can just pull it out from my bag. So we just learned the graph for this function, right?
Yeah.
Okay. What if I ask the graph for this function? That means you're replacing your x with GIF of x.
Okay, fine.
So this
So
we know. This we know how to plot.
Yeah.
This
Okay.
was a process where we started making it fall on the floor. Remember?
Yeah,
We used to make lines like this, and we started making it fall on the floor like this.
Okay.
Okay. But what do we do for such case?
Okay.
So think about this, and if you are done, just show me on the. Can take a snapshot of the paper, pick up the paper where you have drawn it, and send it to me on my WhatsApp.
Okay.
Okay. And tell me the answer for this.
Okay. Got it.
Fine. So let's call it a day now.
Okay.
We'll meet next Sunday, or some plans of having classes in between also.
I don't mind. I mean,
Okay.
I don't mind.
I'll coordinate with ma'am for that. Okay.
Yeah. Okay.
Okay, Arushi. Bye bye.
Thank you.
Have a
Bye.
good day. Bye bye.